Question 1. Determine whether the samples are independent or dependent. So a data set included the daily number of words spoken by 80 randomly selected women and 80 randomly selected men. So this data set, they are independent because separate 80 women, they are in 80 men, and they are not anyhow related to each other. So, and they are not naturally paired between these two samples. So this is independent. Now, which one we would call dependent? Those are, let's say, if we would have data that set that would include morning and evening temperature for last 10 days, let's say. That would be dependent because it's same 10 days and you measure at different time of the day, morning and evening. That would be dependable. Okay? Why is it dependable? Because depends on how much hot or how much cold it was. Then in the evening it can cool down only so many degrees, right? Question number 2. Explain how to perform a two-sample z-test for difference between two population means using independent samples with sigma 1, sigma 2 known. So keywords here, sigma 1, sigma 2 known, and we are using independent samples, right? We are going to perform z-test for difference between two population mean. So sample, so first of all, we are going to step 1. Okay, identify the claim and state the hypothesis test, right? Hypothesis test. Number 2, identify the claim. Those are steps we are going to perform a z-test for difference. Okay, then we need to identify or specify alpha level, which is our significance level of significance. Okay, what else? Based on alpha level, we find critical value, right? Based on alpha level. And once we find critical value, we are going to find standardized statistics. And then we need to compare standardized statistics to critical values. So to make decision, compare critical value to z-test. Okay. Next question, number 3. What conditions are necessary in order to use, let me see. Oh, okay, it's not going down, that's fine. What conditions are necessary in order to use the z-test to test the difference between two populations? Okay, so conditions. First, A, samples have to be randomly selected. Are randomly selected. B, sample must be independent. Samples are independent. Because it's asking, right, between two, necessary in order to use the z-test to test the difference between two population means. They are independent condition. So, and also they have to be, have normal distribution. Normal distribution. And very important condition, if you read, if you watch the video, then you should know to do z-test, you have to have sigma for population, right? Because if population sigma is not known, then you can't apply z-test. It's going to be t-test. Okay? Question number 4. Let's see what we have. Classify two given samples as independent or dependent. So we have the test score of 32 students who had less than 8 hours of sleep the neighbors the night prior to taking test. The test score of 35 students who had at least 8 hours of sleep the night prior to taking the test. Okay, what do you think? Is this independent or these are dependent? In this case, these are independent because we are talking about different students. There is no evidence that these students are anyhow related or those are same students. So the answer is going to be independent samples. All right. Next, question number 5. Again, we need to identify a dependent or independent. So the gas mileage for 59 trucks and gas mileage for the same 56, the keyword same. Well, there we go. I don't need to continue reading. Dependent. Question number 6. Use the technology to display, to make decision to reject or fail reject null hypothesis. Alpha is equal 0.1. Let me write down. So let me move up here the table. Okay, what do we have? We are given alpha. We need p-value, right, to compare with alpha. Our p-value, this one, p-value is equal 0.2994 and blah, blah, blah. Okay, so let's draw it. Reject or fail to reject null hypothesis. I will make the decision using standardized test statistics, using p-value. Assume sample size are equal. Okay, so our alpha is 0.1. They forgot they should add here, it's left tail. So we're gonna assume left tail because only in this case, if alpha is equal 0.1, then p-value is 0.2994 is falling in this area, right? Which means we fail to reject null hypothesis. If it would be right tail, then we would reject null hypothesis because it would fall in this tail area. Reject null hypothesis because p-value is greater than the level of significance. Okay. Question number 7. Test a claim about difference between two population means, mu1 and mu2, at the level of significance alpha. Assume the samples are random and independent and the populations are normally distributed. So all conditions are there to be able to calculate or do hypothesis test for mean between two samples. All right, our claim is mu1 equal mu2. So null hypothesis is going to be our claim. Let's write down. Oops. Mu1 equal mu2. Hence, alternative, it's going to be mu1 is not equal. Next, we need to find standardized test statistics. Because our standard deviation is different, sigma 1 is equal 3.4, sigma 2 is equal 1.7. That means the variances are not going to be equal, because what is variance? Is a square of standard deviation, right? And because it's not, variance is not equal, then we are going to use for standardized test statistics, we are going to use the formula. Hold on. Standardized test statistics is equal. So x1 minus x2 minus mu1 minus mu2, and we divide by sigma, standard error, we call x1 minus x2. Okay, so sigma x1 minus x2 is in your Excel, and that is, let me see, in the worksheet 1. Okay, so I'm going to plug the data. So what is it? Sigma 1 is 3.4. Plugging in. Sigma 2, I have 1.7. All right, plugging in. N1 is 31. And N2 is 26. And I am getting my sigma error. Let me write down. So Excel give me sigma x1 bar minus x2 bar is equal 0.695742. Okay, so next I have to divide, right? The difference, x1 minus x2, let's see. So this is going to be equal, x1 is the 18 minus 16, okay. Minus, I'm going to do minus 0, because when we are testing, we assume what now the null hypothesis is true, which means M1 is equal M2, and that means the difference is going to be 0. And we divide by 0.695742. Let me see. So practically I'm going to divide by 0.65695, I'm sorry, me clean, 2 divide by 0.695742, and I am getting how much? I'm getting 2.87. I'm rounding till 2 decimals because this score can be only 2 decimals, right? Based on table. Okay, next I have to identify p-value. So if you go to this score table, and from table, p-value will be for z-score equal 2.87. You should get 0.004. So you need to round till 3 decimal places here. And what do we get? What result do we get? Our alpha is 0.004, I mean p-value 0.004, and our alpha is 0.001, right? Alpha is 0.01. Obviously, our p-value is less than alpha. Therefore, because it's less than, therefore, we reject null hypothesis. And since our claim is null hypothesis, so then we are not dealing with alternative, and we draw conclusion about null hypothesis. And we say we reject null hypothesis, and there is enough evidence to reject the claim at 1% significance level. This is 1%, right? At 1% significance level, so reject the claim. And the whole sentence you can form it already. Okay, moving to next question. Number 7. No, number 8, I'm sorry. So, what do we have here? Let me adjust a little bit, it's not seen. There we go, much better. All right. For the given data, find test statistics, find standardized test statistics, and blah, blah, blah. So let's write down what we have. So we need to write down, first of all, test statistics. A, our test statistics is saying that our claim is mu1 less than mu2. Let's write down. That's our alternative hypothesis. So mu1 less than mu2, and this is our claim. Accordingly, null hypothesis is going to be mu1 is equal mu2 or equal greater than mu2. One or another. Both ways considered correct. Okay. So, since x bar, which is x1 and x2, are representing mu1 and mu2 accordingly, then standardized test statistics is going to be x1 minus x2, which is going to be 1215 minus 1185. And that is going to be how much? 0, 11 minus 8, 30. That's it, 30. So it's going to be 30. So standardized, no, not standardized, just test statistics, it's going to be 30. Next, we are going to find standardized test statistics for mu1 minus mu2. Standardized test statistics. In this case, we are going to use formula for standardized test statistics, and that is going to be x1 minus x2, right? And minus mu1 minus mu2 over sigma x1 bar minus x2 bar. Okay, well, we are turning to Excel template again to find our standard error. So x1 minus x1 bar minus x2 bar, we already have it, is 30. mu1 minus mu2 is going to be 0 because we assume that they are equal, right? Null hypothesis assumes that they are equal. Now let me go to Excel. Do you think only you are going to use template? I'm using also because I don't want to calculate every single time, so I'll just plug the numbers. So I'm entering that work on Excel worksheet 1. So where sigma, let me write down, sigma x1 minus x2 is equal sigma 1 squared over n1 plus sigma 2 squared over n2 square root. Okay, so let's enter what I have here. Sigma 1 is 80, sigma 2 is 115, excuse me, 80, 115, and 1 is 35, sample size 1, and sample size 2 is 75. And voila, I have the standard error, which is going to be 18.95232. Okay, now 30 divide by 18 point and the whole 9 yard, and I am getting the result. Let me see, punch the numbers, and I'm getting 1.58. As you can see, standardized test statistics I round till 2 decimals because table work only with 2 decimals. Now, in this case, we don't have alpha, so we are, we have alpha, so we can do either p-value or a rejection area. So it's asking for rejection area comparing to either p-value or comparing to critical value. So I'm going to go with critical value, I guess, this time. Okay, so what am I going to do? We have left tail, so alpha 0.01. If I go and check 0.01 alpha, so for alpha equals 0.01, the critical is going to, so an energy company wants to choose between 2 regions in a state to install energy producing wind turbines. A researcher claims that wind speed in region A is less than wind speed in region A, in region B. To test the regions, the average wind speed calculated for 90 days in each region. Here we go. Each region, sample size, 90 days. So N1 is equal 90, N2 is equal 90. The mean wind speed in region A, so average mu1, okay, x bar, because we are using sample, x1 bar is region A is 13.9. And assume per hour, assume the population standard deviation, which is sigma 1, is 2.8 miles. The mean wind speed for region 2, which is x2 bar, is equal 15.3 miles. Assume population standard deviation, sigma 2, is 3.2 miles. At alpha significance level 0.05, can the company support the researcher's claim? Okay, so we are going to complete one after one. So, first of all, we are going to build our claim. So what is it going to be in this case? It's claimed that, here it is, it's claimed that the wind speed of region A is less than, right? That's mean we have our claim alternative hypothesis, mu1 less than mu2. That means null hypothesis, mu1 greater equal mu2, or they put sometimes only just equal. We have our now hypothesis test, and the first the question is what is the claim, and the claim is mu1 is, let me write down, this is the claim, mu1 is less than mu2, which means the wind in region A is less than, the speed of wind is less than in region B, which means we have left tail statistics, right? Okay, now we need to find critical values. Okay, we are going to find critical values, and then it looks like we will compare critical value to standardized test statistics. Okay, critical value, our alpha is 0.05, and if you use the table for left tail, because our z-score table shows left tail anyway, so your z-critical for alpha equals 0.05 is going to be equal negative 1.64. Why negative? Because we have left tail. Okay, now we need to find a rejection area. Okay, to find the rejection area, we are going to see our z critical is negative 1.64. So our rejection area gonna be, if our z statistics is gonna be less than z critical, right? Let me rewrite. It's gonna be less than z critical, right? It's question B. I don't even know, B or C. Yeah, I think, yeah. So it's gonna be rejection region if our z standardized z test statistics will be less than z critical, which means z has to be less than negative 1.64. Yes? Okay. Now let's find standardized test statistics and see how much we are going to get. And we are turning to our Excel template. So let me plug real quick what do we have, and we calculate. It's the same worksheet number 1. So I am plugging sigma 1 is 2.8, sigma 2, where is it, 3.2, N1 is 90, N2 is 90, they are equal, and I'm getting my sigma x1 bar minus x2 bar is equal, how much I got? I got 0.448206. Okay, so from here, if I plug in the formula, z standardized is going to be equal x1 bar minus x2 bar and minus, well, I just might as well put 0 because always going to be 0 here, and sigma x1 bar minus x2 bar, and as you know, sigma x1 bar minus x2 bar, it is our sigma 1 squared over n1 plus sigma 2 squared over n2. And once I plug it, it's going to be x1 is 13.9 minus 15.3 and divided by 0.448206, and my standardized statistics, it's going to be, test statistics is going to be negative 2.77. So negative 2.77 comparing to Z critical is negative 1.64, right? So it's a left tail, negative 1.64, and Z critical is going to be negative 2.7, and Z standardized negative 2.77. What does that mean? We reject null hypothesis, and to do interpretation, there is enough evidence to support alternative one, because our claim is alternative. If we reject null, then we fail to reject alternative. Okay? And if we fail to reject, that means there is enough evidence to support alternative one, which is researchers claim that the wind speed in region A is less than the wind speed in region B. Okay, I am going to wrap it up and post it so you can start working, and I will continue working from the 10 to 18. Okay?